everyone! At the end of this video lesson, you are expected to differentiate rational functions, rational equations, and rational inequalities. Identify the domain and range of rational functions and graph rational functions. Let's have this scenario. The budget of a student organization is split evenly among its various committees. If they have a budget of 2,500 pesos, construct a function m of n which would give the amount of money each of the number of committees would receive. You got it right! The function would be m of n is equal to 2,500 over n. And that is a rational function. Now, let us differentiate rational functions from rational equations and rational inequalities. But before that, let's first have the definition of a rational expression. It is an expression that can be written as a ratio of two polynomials. So, when we say polynomials, the exponents of the variables must not be negative or a fraction. The variables must not be inside a radical. For example, 2 over x, x squared plus 2x plus 3 over x plus 1, 5 over x minus 3. All of these are rational expressions. Alright, let's have these practice exercises. Tell whether the following algebraic expressions are rational or not. X squared plus 2x plus 1 over x minus 6. Alright, this is a rational expression since the numerator and denominator are both polynomials. How about this one? 1 over 5x squared. Yes, this is a rational expression since the numerator and denominator are both polynomials. The numerator is a polynomial of degree 0. About this one, square root of x minus 1 over x cubed plus 4. You are correct. This is not a rational expression since the numerator is not a polynomial. Why? The variable x is inside the radical. How about this? X raised to the power of negative 1 plus 10 divided by x to the power of negative 4 minus 5. Yes, this is not rational since the exponents of the variables are negative integers. Now let us define rational equation, inequality, and functions. First, what is a rational equation? A rational equation is an equation involving rational expressions. For example, 5 over x plus 8 over 3x is equal to 1 over 6. Take note that the word equation means equal. So, this symbol here is your clue. How about a rational inequality? A rational inequality is an inequality involving rational expressions. Example, 1 over x plus 7 is lesser than or equal to x squared over 2. So there are symbols used to denote rational inequality. These are lesser than, greater than, lesser or equal to, and greater or equal to. How about rational function? Rational function is a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomial functions and q of x is not the zero function. That is, the denominator is not equal to 0. For example, f of x is equal to x squared plus 2x plus 1 over x plus 6. Take note of the notation f of x, which is equal to y. How is rational function different from rational equations and inequalities? A rational equation or inequality can be solved for all values of x that satisfy the equation or inequality. A rational function, on the other hand, expresses a relationship between two variables such as x and y and can be represented by a table of values or a graph. Alright, let's have this set of practice exercises. Determine whether the given is a rational function, rational equation, rational inequality, or none of these. Number 1. 2 plus x over x minus 1 equals 8. Very good. That is a rational equation. Number 2. X is greater than the square root of x plus 2. Definitely none of this. Number 3. F of x is equal to 6 minus the quotient of x plus 3 and x squared minus 5. And that is a rational function. Number 4. 2x is greater or equal to 7 over x plus 4. That is a rational inequality. Number 5. X over 2 equals 4 over x plus 9x cubed. It's a rational equation. Let us now focus on rational functions. How do we find the domain and range of rational functions? The domain of a rational function f of x equals n of x over d of x is all the values of x that will not make d of x equal to 0. Finding the range of rational function is done by finding the domain of the inverse function. Another way is to find the value of horizontal asymptote. So let's have example number 1. F of x is equal to 2 over x minus 3. To find the domain of this function, we equate our denominator to 0. X minus 3 is equal to 0. X is equal to 3. The domain of f of x is the set of all real numbers except 3. So 3 here is a restricted value because when we substitute it in the denominator becomes 0 and the function becomes undefined. So the domain can also be written in set builder notation in this manner. Finding the range of rational functions can be done in two ways. The first one is finding the domain of the inverse function, and the second one is finding the value of the horizontal asymptote. Let's do the first one, finding the domain of the inverse function. And how do we do this? So first, write y instead of f of x. So we write y here instead of f of x. Next, we interchange x and y. So, interchange places. Write x instead of y. Write y instead of x. Next, solve for y in terms of x by, of course, multiplying. So, we get x times y minus 3 is equal to 2. Then distribute. We are going to have xy minus 3x is equal to 2. Then transpose negative 3x. We are going to have xy is equal to 3x plus 2. Then divide both sides of the equation by x. So that we're going to have y. Y is equal to 3x plus 2 over x. So look at the denominator. The denominator is x. So our restricted value will be 0. Now the range of f of x is the set of all real numbers except 0. Example number 2. F of x is equal to x minus 5 over x plus 2. What do you think is the domain of the function? And what is the restricted value? Very good. So, the restricted value is negative 2. The domain of f of x is the set of all real numbers except negative 2. Still, by using method number 1, which is finding the domain of the inverse function, let's find the range of our rational function. So we write y instead of f of x. So we have y equals x minus 5 over x plus 2. Then interchange places, interchange x and y. After which, cross multiply, so the result is x times y plus 2 equals y minus 5. Then we distribute x. We have xy plus 2x is equal to y minus 5. Then transpose y so that all of the terms with the variable y will be on the left side and the rest of the expressions on the other side. Then factor out y. So xy divided by y is x. Negative y or minus y divided by y is negative 1. So y times x minus 1 equals negative 5 minus 2x. Then divide both sides by x minus 1. We have y equals negative 5 minus 2x over x minus 1. So look at the denominator. The denominator is x minus 1. We equate it to 0. X is equal to 1. Therefore, the range of f of x is the set of all real numbers except 1. Example number 3. F of x is equal to x minus 4 times x plus 2 over x minus 3 times x minus 1. So we find the domain by equating x minus 3 to 0 and x minus 1 to 0. Then we have x is equal to 3 and x is equal to 1. Those are the restricted values. So the domain of f of x is the set of all real numbers except 3 and 1. Let's now have the other way of finding the range, which is by using the value of the horizontal asymptote. Let n be the degree of the polynomial in the numerator and m is the degree of the polynomial in the denominator. Recall that degree of the polynomial means the highest exponent of the variable. So if n is lesser than m, your horizontal asymptote is y is equal to 0. If n is equal to m, the horizontal asymptote would be y is equal to a over b, where a is the leading coefficient and of the numerator and b is the leading coefficient of the denominator. When n is greater than m, there is no horizontal asymptote. So take note that the value of the horizontal asymptote would be the restricted value of the range. Let's go back to example number 3. So for us to be able to use method number 2, the horizontal asymptote, let us first expand the numerator and the denominator for us to identify n and m. So the result is x squared minus 6x minus 8 divided by x squared minus 4x plus 3. Next is we identify n. So the highest or the degree of the polynomial in the numerator is 2. alright, the highest exponent, then the degree of the polynomial in the denominator is again 2. As you can see, n is equal to m. So we have the second one, which is y is equal to a over b. So what is a? A is the leading coefficient of the numerator. So the coefficient of the variable with the highest exponent, that is 1. Then for b, the coefficient of the variable with the highest exponent, again, it's 1. So 1 divided by 1 is equal to 1. The horizontal asymptote is y is equal to 1. The range of f of x is the set of all real numbers except 1. Well, number 4. F of x is equal to 3x minus 9 divided by x squared minus x minus 6. So for us to be able to find the domain, to find the restricted value, we factor out the denominator. So the denominator becomes the quantity of x minus 3 times x plus 2. Then equate them to 0. X minus 3 is equal to 0. X plus 2 is equal to 0. So the values are 3 and negative 2. Therefore, the domain of f of x is the set of all real numbers except 3 and negative 2. How about the range? So, using method number 2, using the value of the horizontal asymptote, we use the expanded form. F of x is equal to 3x minus 9 divided by x squared minus x minus 6. So, what is the value of n? Very good, it's 1. And the value of m is 2. Now, 1 is lesser than 2, right? So, y is equal to 0. Okay? The range of f of x is the set of all real numbers except 0. How do we graph rational functions? So there are concepts that we need to review because these concepts will help us in graphing rational functions. The domain of a function is the set of all values that the variable x can take. The range of the function is the set of all values that f of x or y will take. The zeros of a function are the values of x which make the function 0. Intercepts. They cross the x-axis or y-axis. Y-intercept is the coordinate of the point where the graph crosses the y-axis. X-intercept is the coordinate of the point where the graph crosses the x-axis. An asymptote is a straight line associated with a curve such that as a point moves along an infinite branch of the curve, the distance from the point to the line approaches 0 and the slope of the curve at the point approaches the slope of the line. Vertical asymptotes are the restrictions on the x values of a reduced rational function. To find the restrictions, equate the denominator to 0 and solve for x, just like what we do when we solve for the domain. Horizontal asymptotes. Let n be the degree of numerator and m be the degree of denominator. If n is lesser than m, y equals 0. If n is equal to m, y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Now, if n is greater than m, there is no horizontal asymptote. Let's have this example. Graph f of x is equal to 7 over x. But first, let's determine some guiding concepts. For instance, domain. So the domain of the function is the set of all real numbers except 0. So in our table of values, we are not going to use 0. x-intercept. Substitute 0 to y to solve for x. But 0 is not equal to 7 when solved, so there is no x-intercept. What does this mean? This means that the graph of the function will not passing through the x-axis. Y-intercept. Substitute 0 to x to solve for y. But as you can see, our y here is undefined, so there is no y-intercept. This means that the graph of the function will not be passing through the y-axis. Vertical asymptote. So the restricted value in our domain is also the vertical asymptote. So x is equal to 0. So our graph will just be approaching this line but will not cross through it. Horizontal asymptote. So utilizing the previous method that we had, we look for the value of n and m. So n is 0 and m is 1. So n is less than m. So the horizontal asymptote is y is equal to 0. Again, our graph will just be approaching the line y is equal to 0 but will not cross through it. To graph the function, we can use a table of values. So for instance, I use the x values of -4 up to 4 and solve for y. You can then plot the values in the Cartesian plane and you are going to have this rough sketch. Using any graphing app, Desmos, GeoGebra, and others, you'll have this actual sketch. You may compare it to your work. So Desmos can actually be downloaded for free and installed in your mobile phones and laptop or computers. Thank you very much, and I hope you have learned something in this video lesson.